Hi everyone, can you hear me? Hello everybody.
Hello.
Hello.
We've still got people coming in.
Right.
Wow, there's a few more of you than I expected. A couple more joining us. Right, so how's everybody doing?
Good this end, Louise.
Good to hear.
Very good.
It's so busy today. Right, we've just got some more people joining, then we'll start shortly.
Morning all.
Morning. Oh well.
Morning.
We've just got a few more people coming in. Oh, and the godfather of LEVs here. Right, well, the people joining in is slowing down now, so I think that's about it. A second.
Are you hiding, Louise, or is it my camera, my screen?
My camera is actually not working.
That's lucky for you.
Dropped my laptop on the side, didn't I?
Oh, that's bad.
Butterfingers. Everything else works but the camera.
Whoops.
Not that you want to see my ugly face anyway.
I did the odd makeup trick.
Oh, I didn't have a trowel today. So hello everybody, I think that's about it for everybody joining. We've got 19 in the meeting. I just wanted to make you all aware that we are recording the session today to make it available to other members of LEV Central. There's one or two that wanted to be present who couldn't make it today because they've had to work or whatever. And I wanted to start actually, there's a lot of people private message me on LEV Central on LinkedIn questions that they're not brave enough to ask the wider audience. So I just wanted to put some questions out there first. So question A, if I follow the BOHS Breathe Freely selector tool and a different type of LEV is given in the results to the one my client has, should I be failing the existing LEV plant as it doesn't match the selector?
That's a really good one, Louise, because I've been looking at that recently on training courses. And I am finding that there's a lot of welding systems out there that are maybe not to the benchmark. And it's kind of, where do you stand? Because at the end of the day, in terms of responsibilities, it's the client's responsibility to ensure that there's an overall risk assessment. And it might be
Yes.
that a downdraft booth is the most ideal situation, but they might have something like on tool extraction as well as hoods to protect them. At the end of the day, is the person protected? So I find it very difficult going on client sites and testing something like a welding system, especially if it's a capture hood, because it's kind of, well, this isn't benchmarked for a welding process. And then we're in the situation there. Can we pass it if it's not benchmarked? Well, the only way I could feel comfortable passing it is if I can see they've got a written down risk assessment that's also got additional controls and they match what's in the guidance. So WL3 is really good because it goes through like how often do you use it and blah, blah, blah. If you can't get that information off the client as a tester, that's a really tough one. I don't know what other people think. I'm of the thoughts when I do a test for this kind of situation, then I can only give information on how well that system works. So if it's a capture and maybe a portable capture welding hood, I can report, yeah, it's in really good condition. This is the capture distance that it needs to work in. The filters are in good condition. It's okay. However, depending on your risk assessment and your process, you'll also need additional controls. So I can't actually give them a pass. I can only give them a sort of conditional, yes, this will work within a certain distance with other controls in place. So for me, it's a really tough one because I don't feel that you can yes or no it without that risk assessment.
That's a very good point, actually.
Yeah,
Anybody else have any thoughts?
The LEV system is only, part of a suite of controls, and it can be a mixture of LEV and RPE. I certainly wouldn't fail something because it doesn't meet the criteria of the selection tool. But a lot of the places we work are offshore and large construction, and where there's no way a downdraft bench can be used, and an extraction arm certainly is not perfect, but it combined with RPE and other sorts of ventilation, then it's obviously trying to get exposure down to a reasonable level. So it's I certainly wouldn't fail something because it's not a downdraft bench, as the selector tool would say. But of course, a downdraft bench will only be the answer if it's small to medium sized parts, I suppose, on the selector tool.
Yeah, and not large plates either.
Yeah.
Okay, another question that came in this morning. Sorry,
it's the same with I suppose the 1 meter per second and the 0.5 meters per second. It's very, very difficult to explain to a welder when they can actually see all the smoke or all the weld fume going into the hood that, from a distance of say 300 mil, that you have to position that hood to 150 mil. I know there was discussions recently on LinkedIn regarding capture distance, and also I find it's a very, very difficult argument to make on site when they can see with the hood being positioned at a certain distance, it's taking all the fume away. So that's I suppose another side to it.
Yeah, and that was actually a question that was emailed half hour before this meeting, actually. It says everyone's doing Fletchers on Bill's oxalate app for capture distances, but I've always done smoke and tape measure minus 50 mil. The capture distance via Fletchers is much less with smoke, and I follow the crowd, but how do I phase Fletchers in to replace previous smoke assessments? Because I'm getting backlash from clients.
Mm-hmm. I get dragged back onto site recently because I relabeled hoods that we had previously put on a label. I shortened the capture distance for 1 meter per second and was dragged back up to a site in the northeast to face questioning. It's a difficult thing, yes.
People have to understand how Fletcher's is calculated and how it's used. And Bill, you probably had to give more on this than I can. But Fletcher's is very theoretical and has the hood angled at a horizontal position, whereas a lot of the time on welding fume, the hood is either above or angled at 45 degrees and above. So you get a much greater capture, what appears to be a capture distance, because the hot buoyant fume is rising into the capture zone and then it's taken away. So you're not comparing apples with apples.
I suppose the important thing as well is watching the welders do the weld as part of your qualitative assessments. Are they positioning it somewhere near? Because that's half the battle, isn't it? Half the welders don't use the hoods properly.
Louise, if we can go back to the beginning of that question, the smoke in still air conditions will be controlled down to 0.2 meters per second. I've run it experimentally several times. So in complete still air conditions, I'll put to one side the very good point Adrian makes about the positioning of the hood, but smoke will be controlled down to 0.2 in still air conditions. I don't know, even given my elderly years, I don't know what the origin of the 0.5 to 1 meter per second, but it clearly has a built-in safety margin that they have decided at some stage, which predates me, that 0.5 was the minimum and 1 was obviously the upper end of the range. Now that then becomes a problem when you do a pure smoke test and you show that it goes out to 300 mil, you run it through Fletcher and it says 200 mil, and you end up putting a sticker on it 200 mil, and the client's not terribly happy because they could clearly see the smoke going, control going much further. So that's one point we'd need to explain to the client that the smoke, yes, that's a test, but it's showing 0.2 in still air. I think what happens is that in many situations, welding hoods are used as mongrel hoods. They're kind of part capture, part receiving hood, in the sense that they're at a bit of an angle, so they're getting the buoyancy from the hot fume as well. So in reality, they do perform better than full sideways on, which then leads to another question that I know has been put up by a number of people, which is, how do you test a welding hood? Do you test it as you found it, but then that afternoon the welder may turn it sideways on rather than having it at an angle overhead? Or do we have to standardize so that we've got a reference to work to each time we come in? That's not really been discussed widely, I don't think. Anyway, that's my input on the smoke. Discussions with the guys at HSC have shown that they would prefer that you use something like Fletcher to calculate it, but then to prove it by using smoke, that it goes at least to the Fletcher distance that it produced. And that's to prove that there's no extraneous drafts, air currents and whatnot pushing it away before it gets to that position. So that, as I understand it, is the current view on testing welding hoods. But yeah, I mean, for many, many years, Louise, I did it by releasing smoke and coming back 50 mil.
Yeah, anyway, I was the same.
I'll be quiet now.
I don't want to get around it by telling the customers that the regulations have changed. They never question what the regulations are, or they haven't to date, touch wood, and they seem to be satisfied with that.
I wouldn't use the word regulations, because you can get caught out with that one, Louise. I would use expectations or protocols or standards, but I wouldn't use the word regulations. You're going to get caught with that one.
Yeah, I think in terms of what to say to the customer, what I've found useful is just to say more recent research has shown that this is the most accurate method. Now, what you're putting on the hood is the safest scenario. And my answer back to them would be, because I feel really uncomfortable with LEV testing without sampling data, because I can't say whether someone's getting exposed just by looking. You can usually tell if there's a problem, but how do I know that the result is reasonably practicable, or are they not exposed at all? That's not something I could say without some quantitative data. And quite often customers don't want to pay for sampling as well as the LEV test. Now, I don't have a choice in that. I can offer it, but if they pay for it or not, that's up to them. So my only advice is to them to say, this is the current methods that we use. Based on research data, it's the safest. And if it's quite possible it might work further away, but you would need to use sampling data to prove it. So if you want to work within 300 mil, then feel free to get some sampling done on the person when they're doing normal tasks, and just see are they getting exposed at that distance. Now, you may be able to find that actually 300 mil is a safe distance. Personally, from experience of actually watching the welding process, and I use this example in training every time when we talk about Fletchers. I did some LEV testing on a big welding site, and there was one particular capture hood in one of these booths, you know, where there's just a tiny little booth with a workbench and a curtain behind them. And I used to do my testing over lunch when they're all on the dinner, so I'm not interfering with the job. And I did my testing. I had one of those big concept, is it, or the heat soup smoke machines, and I released it in front of me. I stood as if I was the worker, and I released it over the full bench, and it was absolutely whizzing up the hood. And I'm thinking, this hood's got some good flow on it, it's great. And then after my testing, what I normally do is walk around and watch all the processes. So I'm walking towards this enclosure, and out of the top of it, I can see fumes. And then I'm starting to panic, thinking, oops, I've turned it off and not turned it back on for the guy over lunchtime. So there's me panicking, running up there to say, I may have just turned your extraction off. Turned out it was actually on, and his welding fumes were coming out the top of the booth. So although it was great with smoke, I think those values 0.5 to 1 are going to be realistic, and surely they've been put in that guidance document for a reason. More than likely I don't know the background behind where those figures came from, but more than likely it's been some studies. And as Bill says, smoke will get captured at 0.2 meters per second, which I saw in that example. And then once he starts welding, it was actually evading the hood and going straight up out the top of the booth. So that's the only advice I can give, and to explain that to a client, just to say in the past it's been done in good faith with smoke testing, but research has shown that smoke gets captured different to welding fume, and we're going on the guidance on current research. I don't know what others think or their experience is.
Is that just because it's a different density to smoke?
Yeah. So the fume has lots of particles in it, and it's very dense, and it will act in air in a different way to smoke would.
So John Saunders at the HSE, and I don't know if John's on this call or not, said at the last LEV conference last year, was it last year or the year before, 0.5 to 1 was an indicative number put out there back in the 70s or the 60s. Been around for a long time as a sort of guidance number, and there's no hard fast sort of science behind it. But I think we're trying to pin this down to an exact sort of number, 5 to 1 or whatever you want to say, when the real world isn't like that. We're talking about welding. There's lots of different types of welding, different processes, different angles, different size rods, how much smoke they produce. We've got to test what's in front of us. And 0.5 to 1 may not be good enough. You may need more. It's about control, isn't it? Is it controlling or not? You might be getting 1 meter a second. It might be 200 mil from the hood. If it's still not controlling, it's not controlling. So we need to be looking above the numbers and actually testing what we're seeing. What do numbers do? We just record them. Just because you've got 1 meter a second doesn't mean you've got control. It's just something we can record and refer back to next year and the year after. Yeah. So I really wouldn't get too hung up on what the number tells us. Yes, the working zone is important, and people need to know that so they know they're working in the right place. But the actual 0.5 to 1, to me, sorry, it's just a number.
Could I draw some comparisons here, Adrian? We at the moment, we use some devices in laboratories that are very similar to the welding hoods. They're articulated extract arms, and there's a new standard that's going to be coming out for public comment very soon. And what I would like is everyone that's in on this call to drop me an email so that I can send them a copy of this document when it comes out to public inquiry. Because in this document, there is a type test for an articulated arm, which is, for all intents and purposes, the same as a welding arm. It has the same configurations. It works on the same principles. But in this test, what the standard is prescribing is that the evaluation will be made on velocity to start with, where they will just move away from the capture device in 20mm increments until a velocity of 0.4 meters per second is no longer obtained. Then they will call that the capture zone. But then they're also having a test whereby they have a small sensor that's linked to a gas analyzer. The sensor is placed inside the duct arm of the capture device. They then release a known quantity of a particulate gas underneath the capture arm, and then they measure inside the duct how much of that gas is being collected by that capture device and sending into the arm. They have an additional part to the test, that they have a 400 millimeter wide by 1.9 meter high plate that's on a rolling table that moves across the front of the capture device while it's performing, so to cause some sort of disturbance. Now, this is only, what I'm trying to get back to here, this is only recorded in this draft standard at the moment as a type test for manufacturers to perform. And what I'm trying to say is, how do we transfer the test to the as-used application? And we're coming back to the same problem that I think you're all finding here with the welding devices, in that we can only ever record the numbers.
Yeah,
I think this has to be thrown back at the manufacturers. If they're bringing these devices to the market, they know there's a statutory obligation to have them tested, and as part of their O&M and their user manuals, they should be telling us how they should be tested. But we're not seeing it. You know, we're seeing it across the board in the construction industry with these new saws and tools coming out with extraction devices on there. There's no way of testing some of them, apart from doing a visual assessment. And these arms are the same, Melvin. The manufacturers should be saying, this is what we do in the laboratory. This is what works. Now, when you test it on site, you need to do this.
I agree, but since the Grenfell inquiry and Dame Judith Hackett's work, the UK government has now instigated a new code of practice that's they hopefully are going to be launching, where they're placing a greater emphasis on the way manufacturers report information and the efficacy that that information has to have, and how it's transferred to the user, not just to place it in a manual that's stuck in a box and sent out. They're trying to move it forward in that the information is made more widely available, but also is more practical. The thing I struggle with particularly is that manufacturers perform type tests in such intrinsically perfect conditions that, you know, even a cardboard box with a hairdryer on would pass the test. You know, if you're going to test an articulated arm in a room where the thermal air conditions are below 0.05 meters per second, there is going to be no challenge. I mean, just somebody with sedentary breathing can breathe at 9 meters a second if they're bending over. So the way they perform these tests, and this is where, for me, the problem lies. It's great to have a manufacturer's type test because it does allow people to evaluate a range of products. But you cannot use that. You cannot use that to make sure your guys are safe on site.
Yes, I agree there, Melvin, with you entirely. I think type testing can and should be done by the manufacturers to give an indication. Adrian's right.
You haven't got anything else.
They seem to be.
So nobody's walked off with anything.
Oh, if I get over. Yeah, I think manufacturers are not giving the information that one would expect. There should be some indication of efficacy of their systems. Even a simple graph that says this is the size of the hood.
No,
if you achieve
there's nothing under there.
If you achieve a
Can't
face,
get under there.
I've got somebody's microphone cutting in, breaking in. You know, you can easily do a graph and a chart. And you can talk about what distance they reckon their hoods would get by way of capture distance in good still air conditions. But I think the point is, once we get on site, then we're in a dynamic situation. It's the way the welders are working, the size of the weld, the type of welding that's been undertaken, the drafts, so the ambient conditions. And one of the questions to you all would be, if you went along and you did some testing, and Adrian's quite right, he says, you know, 0.5 to 1 meter per second is an indication, and you mustn't just get hung up only on that. And you go along and you find that the guys are working at the distance that Fletcher says, and at that distance it should be achieving 0.9 meters per second or something like that. And there is visible plume escaping. What do? Visible plume escaping. Never mind what face velocities and capture velocities. You go along, you observe the welder operating, and you see visible plume escaping. What's your views on that?
My feel originally would be that it was a fail. The captor hood failed to capture all the fume, but the recent information I've been given through training says that the HSE are looking at more controls put in place. So RPE being used, general ventilation being utilised, which I'm a little bit confused about now, if I'm being completely honest, because when first did P602 and 601, that was classed as a fail, where it seems to be doing a bit of a U-turn now.
I don't think it's doing a U-turn, Craig. I think it's still a fail if it's not being used. What we are assessing is that they have adequate control. And if that includes the use of other control measures, such as RPE and general ventilation, then that can still be a pass. The whole control solution is a pass. The LEV may be a fail on its own, but the bottom line is the client has to do a risk assessment, and the risk assessment takes into account all control measures. You can't just, especially welding, you can't just pin it all on the LEV to provide adequate control, because it never will. You know, the HSE say that on-tool extraction is the best form and it only does 90%. Well, how about the other 10%? So that you've got to have secondary controls in place, and it's the whole control solution, not just the one element. So if the LEV is there and it's not being used correctly, i.e. the hoods aren't positioned, personally, I would fail it. And I'd fail it not on the grounds that the LEV is not working, but because they're not providing suitable user training to position the hoods. But if they have a risk assessment which says they have other control measures to prove otherwise, then the client can still carry on and do the task, do the work, because they have the other controls to ensure their exposures are to an acceptable level.
See, Adrian, we would probably take a softer view and say it's a pass, but we'll give you 3 months to get your instruction, information, supervision in place, and check it again in 3 months. If at that 3-month period or whatever period we chose, they weren't then complying and it was still tucked away in the corner, then yes, it would be a fail. I think it comes back to working with clients as well. It's you know, you've got to work with them to a certain degree. And yes, if they're not using it consistently, then it would be a fail. But I think if you go in and it's just if they're all shoved in the corner, clearly not used, then yes, that's an issue. But if you take the example of the photograph you put on LEV Central, that they're using them, just not as well as they could be, then maybe we take a softer view. And I think this is the problem we've got, is the inconsistency and that room for manoeuvre. So some companies will go in and fail it, some will go in and pass it. And this is what the clients are seeing, and this is the frustration the clients are having, is this inconsistency amongst the testing.
With that, the problem is you're getting a lot of companies who are going in and are failing this and charging X amount of money, and the view from a customer's point of view is that you're always going to find someone who will do a job cheaper, who will pass that system. And that's another thing that's concerning, that there are people out in the industry who, with us not being on the same level or aiming to be on the same level, we're always going to have an issue.
What I would like to track back on a little is what Bill raised when Bill was saying that what do you do if you observe that velocities may be compliant or you may have the right conditions, but you do note that fume is being moved around, that isn't being captured. What do you do? I like to think that as testers we can try and be a bit interactive with the user and perhaps suggest the user changes the way he works with this device. So if we're testing it and we're finding that something isn't quite right, we should be suggesting, well, have you thought about changing this process or using this in a slightly different way? Or, you know, I really worry slightly. If I can use a similarity, when I do testing on fume cupboards, a lot of the time there are fume cupboards that fail a test. And what I should do is put a sticker on that says this fume cupboard's failed, do not use. But what I try to do is look at how they're using the fume cupboard. And I've been able to help users by saying, move everything back from your sash line a minimum of 150 millimeters. Try to lift things up off your work surface by a minimum of 25, 30 millimeters. And when they've done that, the fume cupboard that I've just tested that didn't pass the flow rates and the containment values now works. Not because I've done anything with the air volume flow or I've changed the design of the fume cupboard. All I've done is interacted with the user to try and assist them in understanding. And I think one of the big problems we have, all of us, is that we don't always get the chance to talk to users before they get the equipment to use. It's normally wheeled into them. Somebody says, here's your new piece of welding protection kit. You plug it on there, you move it across and you carry on. I feel a lot of this is education.
I think you're right, Melvin. I think a lot of the problems with the industry is education, from the employers all the way through to testers. I do think, and knowing a lot of the people on this call, that a lot of us on this call do educate people when we are testing and do go through those explanations and try and improve the working practices we come across. But you're right, there are an awful lot out there who just test what's in front of them and leave site as quick as possible. But yeah, I mean, Bill and I and Mark and Louise, we've all had that conversation in the past about what's the issue with the industry, and it does boil down to education.
Yeah, I've had very similar views to what Melvin was saying about fume cupboards. You know, the site that I'm permanently based at, you know, it's a pharmaceutical site and it's just full of fume cupboards around the site. And pretty much exactly what Melvin was saying, it comes down to the users or, you know, lab owners that they're not using the fume cupboards correctly. They're poorly loaded. There's too much equipment in there, or it's too bulky, or it's right up to the face of the sash, or, you know, they're not putting things on platforms to create better airflow. And again, it just comes down to not having an understanding of what the impact is of that equipment and the poor loading and putting them at risk.
I think one of the issues that we have in the industry as a whole is that you can have LEV testers that have gone through the P series, and then you can have people that have more of an occupational hygiene background that are also doing LEV testing. And I think if you're expecting LEV testers to have that more occupational hygiene view, then that's something that should be explicit across the sector. Personally, I don't think it's particularly at the moment that we should expect that. LEV testers are coming in and training on an engineering control, and as they get more experienced, they will pick up information, but they're not occupational hygienists. And I think we can provide a good service by offering more of that occupational hygiene advice and support, but that's not really what an LEV test is, I don't think, anyway. So I think that's sometimes where I get a bit concerned is, you know, how far are we expected to go into that area? I think it's great for those of us that can, But if we're trying to develop a sector and standardise training and decide on what level people should be at, how far do you go with the occupational hygiene side and understanding the hazards and how they're using the system and these extra bits that we might do, but the rest of the industry aren't doing?
But I think that's the critical bit, though, and I think that's the failing that we're seeing on so many of these systems, is the right at the start. It's the cost risk assessment. What is the process and the substance under control?
Mm-hmm.
And if the tester doesn't understand that, then you're failing right from the start. And I think from what we see and the experience I've got over the years of testing, that's the critical failure for us. It's that lack of understanding. Everything stems from that. So if you don't understand what the substance is and how it's performed, how it should be controlled, how can you determine whether it's controlling or not?
So
yeah, Mark is correct. I mean, the purpose of the COSH regs is to look at the risk assessment as your first major step. And the risk assessment says, do we need to control those risks further? And then you move to Regulation 7, which says you put in controls. Now, if you look at the definition section at the beginning of the COSH regulations, the controls are obviously the substances, but the engineering controls such as LEV, but also administrative controls and things like supervision and training and so on. So when we say, is the control satisfactory in that it's bringing the risk to an acceptable level, the word control means the envelope, the suite of controls. And there is a worry that I have, is that sometimes maybe we look at the LEV and we say, that is the control, but it isn't. It's all the other things as well. But that then causes a problem for the tester. Is the tester, which he isn't, supposed to be testing the control envelope, or the element of the control that he's physically looking at, LEV? Because the LEV may be doing its job to the best of its ability. That was what I was trying to allude to. The LEV can be doing the best you can expect from it, but the emissions, the process, are not being controlled adequately. And that's where Mark is right. You know, if you get visible plume that's not being controlled, that becomes then an issue of the risk assessment. How significant is that emission that is visibly bypassing? Is it significant or is it not? And I've come back over the years to saying we fundamentally need to look at the risk and the risk assessment and the elements of it. But that's probably beyond the scope of what we do under Reg 9. We do under Reg 9 the LEV testing, which to some extent will be how the people are using it. As we know, paragraph 186 says that we're supposed to ask about occupational hygiene monitoring. So do we look at a welding hood and say, there is some fume escaping? The client, brackets, unusually, has some good occupational hygiene reports which show it's insignificant. The actual welders' exposures were less than 1/10 of the workplace exposure limit for the individual components and so on. I reckon you could then say, well, that's okay. But if there is no occupational hygiene data, then we're straying, as Catherine said, into occupational hygiene, pure and simple territory. Should we be saying there was visible control? And I'm not going to come down on one side or the other, but maybe we should say there's visible emissions not being controlled until such times as a review of the risk assessment has been undertaken, including hygiene monitoring. We can't say whether that's significant or not, and whether your control envelope is working, or do we say something else? But I do think it is back to fundamental risk assessments to determine whether the envelope of control is adequate or not, and what it should contain, and the key points in it, one of which, of course, will be supervision and training.
As an LEV tester, you can only recommend that back to the client, though, unless you are from an occupational hygiene company as well, and you can offer those other services.
Indeed.
So it would be a point of then on the report stating the recommendations of a risk assessment, further work on the other controls to see and sampling It's difficult to know where to leave it. I think sometimes when you're doing an LEV report, how far do you go? And we want to do a good job, but we also need to earn money, and it sometimes is frustrating.
We tend to use our covering letter. We tend to use our covering letter to try and explain a bit further why they need to do more. It's not just about spending more money; it's about the long-term health effects. So I tend to go on a bit in the covering letter, just in addition to the report, to try and help them understand.
I think we do have to do more occupational hygiene element to the work. Not saying LEV assessors need to be hygienists, but there is clearly an overlap there. And I think on the P601 courses, and there's far too many people who get 601 and run out and start doing testing work. It doesn't cover enough of the occupational hygiene element. It clearly, it is an issue. It needs to be linked, and I think in time, LEV test reports should have some form of air monitoring on them. Maybe not full personal exposure monitoring, but certainly handheld equipment monitoring to see what is escaping from hoods, potentially background readings of what's in the air. Because at the moment, it's not good enough. It's better than 10 years ago.
It's the old chestnut, Adrian, isn't it? That a pure occupational hygienist may not be competent to do LEV testing. A pure LEV engineer may not be competent to do LEV testing. It does require knowledge of both. It's this overlaps, the Venn diagram overlap. And I've seen so many people who say they're OC hygienists and they've got certificate in OC hygienists on, and the reports are terrible. I've seen some very good physical installation engineers do LEV testing, and the reports are awful. So it doesn't guarantee you if you're an OC hygiene you can do it, or if an LEV engineer you can do it. It does definitely require understanding of the OC hygiene elements and the engineering elements.
There's a specialist role which, Bill, you and I discussed many years ago, in the middle there somewhere, the LEV assessor, which understands the engineering, understands the OC hygiene, and does the assessments of the LEV and the control it gives. And part of that is considering the risk assessment, maybe helping the client to update their risk assessment, and looking at all controls, not just the LEV. Whether you then have to recommend they bring in specialists to do air monitoring or other types of measurements, then so be it.
How often would you expect occupational hygiene monitoring to be taken out?
Depends on the results you're getting.
It's necessary.
Yeah, it depends what you've got. What you may not need to do any air sampling. If you dust lamp or smoke tests, they may be sufficient. Depends what the substance is, the usage. That's a little bit of a how long's a bit of string question, but yeah, it would depend for us on what concentrations you're getting in air, and that'll determine how often, how frequent. Back to your risk assessment.
If I suspect there's a lack of control, then I would recommend they undertake air monitoring to prove what is in the air.
I think we tend to do this quite a lot when we get together. Is everybody's got absolutely valid points, but we still keep trying to fit a square peg into a round hole, and everybody's saying exactly the same things, and we kind of go around in circles. It's kind of, how do we look at realistically what we've got and what can we do? Because to me, there's various elements to the test, and realistically, and just working with some of the companies that are doing LEV testing at the moment, is if they're going out to do a £70 job, how much time and effort do you put into that £70 job when already you've just travelled a long distance and you've spent maybe an hour, 2-3 hours on site? Realistically, you're not going to get that quality of person to do that type of job for that amount of money. And realistically, these companies are not going to be able to pay, like the smaller companies, like a little woodworking shop or welding shop, things like that. They're not going to pay that amount of money. I think there's a lot of things we can do. We can get some sort of collection of data and standardizations. We talk about these type testings, which you know, they're great in a factory environment where you've got low flows, but then what about when it's put into use? Is that not something where occupational hygienists can start to work together and collect some of that data to put into a database? So maybe the type of unit, so we're talking about a Kemper, you know, portable unit, an Edelman portable unit. We've done some sampling, it was used in this distance. Start to collect some data and collate it and say, well, actually, we've done our sampling and we're getting these levels, and start to see, well, actually, yeah, we can start to feel a bit safe that we're doing these, we're based them on Fletcher's nomogram, and we're seeing that the data coming back, as we've collected a lot of data, it's showing that we're getting good control. Because you're not going to go and test one of those portable units and pay an absolute fortune for sampling every single time. These little shops are never going to pay for massive amounts of money for these tests. It's unrealistic to expect, and it's unrealistic to expect every single person going out doing these tests to be good engineers, mechanically, electrically, knowing their occupational hygiene, knowing the cost, knowing the regulations. It's not ever going to happen.
I disagree.
Thinking,
but it should.
What can we do? We may be able to move in that direction, but that's not going to happen quickly.
See, this is the problem, Catherine.
We're kind of trying to say, right, well, that's where we should be, and not looking at, well, actually, that's where we are now, and these are the steps that we need to take to get there. There are too many engineers out there, and if the whole responsibility of that test engineer is to prove control, I don't know how you make that work, because to me, those visual tests, I don't think they work. Just from my experience, doing a smoke test, comparing that against welding fume, they don't act in air in exactly the same way. Doing visuals with a dust lamp, I can see particles. When I've got the light shining through the window, I can see dust in the room where I'm sat. And if you look at even just basic dust levels, 4 milligrams in a meter cubed of air. Does anybody know what that looks like?
Yeah.
Can you confirm it? That might be something that you visually know how to see 4 milligrams, 10 milligrams. But all of those testers out there, if they see a tiny bit of dust, which you can see that in the air in the room that you sat in. So how do you know the difference between, well, that's kind of normal background levels and that's 4 milligrams of my contaminant? It's kind of, to me, it's not a number. It's not going to make me feel safe. If I start to see dust floating around in the air, then how do I pass that hood? And again, it comes down to the risk assessments. If the LEV testers are not getting all the information off the customer, how can they pass or fail a system? I think there's a big issue with putting the onus on an LEV tester in terms of saying whether something's controlling. There's a lot of things. There's benchmarking. A tester, yeah, I think it would be reasonable to expect testers to learn how to benchmark a hood and to be able to say, well, actually, it's not the best benchmark, so, or it's not the right benchmark for the process, but it may be used with other controls. Again, goes back to the risk assessment. Are the flows meeting the guidance flows in HSG 258? It's either yes or no. Some might be meeting, but not controlling. Some might be lower, but actually the control, you don't know. They're just numbers, like Adrian says. But we can record those numbers. A tester can record those numbers. There's your visual assessments where you can say, well, I've used a dust lamp or I've used smoke testing, and visually, I have not seen a problem. I don't think I could visually do an assessment and say, yes, you've got control. I can just say, no, I haven't seen a problem. I'm not seeing any indications of anything moving out of the hood or away from the hood. However, I can't confirm there's no dust in that breathing zone without a number. The element of control is the big sticking point. And we're expecting LEV testers to go into places in the current situation where it's a woodworking machine. There's woodworking dust scattered all around. Quite often it's from a chop saw that they're using without an LEV on it. So yeah, do we keep failing systems, and then that company's kind of like, oh, well, my system's failed, that's the problem? You know, there's too many grey areas, and we're putting the onus of an LEV tester who's getting a snapshot of information and not always given a risk assessment to say, is there control for that worker in their breathing zone? And I think we need to try to look at how realistically can we, I think in terms of commissioning and supplying systems, we still have that big loophole where the suppliers, there's a loophole that maybe they're not commissioning the system. And it's that those grey areas that we need to look at. Do we need to make it where somebody who supplies a system has to then prove it in use and prove control? In which case an LEV tester then has that benchmark. They don't even need to worry about how good their occupational hygiene is, because in that ideal world, yeah, we've got that working. But the world that we're in at the moment, what percentage of systems are properly commissioned with sampling data, with enough information for you to go in as a snapshot to say, yeah, they've got control there. I'm quite apt to put my name against, yes, you've got control, with no... You've not got the information. You can't do that. You can't expect LEV testers to walk in, test these systems and say, yes, this person's got control. In the current situation that we're in, we need to find a way, how do we manage that? And I think there's a lot of things that an LEV tester can do, but I think putting that onus of does it control without them doing sampling or quantitative or having good commissioning data to start with, things are not going to move forward unless we do something, unless we think about how do we do something different to make this work. That's my opinion anyway. So I don't know what others think, but I just think we can't keep expecting someone to say, yes, you've got control, without them having risk assessments, without them having quantitative numbers.
I think on the air sampling aspect, Catherine, I think obviously it brings in what Dean was asking about on the LinkedIn group for the LEV Central, was the recirculating air units and who's actually taking air measurements for those. How are you taking them? Where are you taking them? How often are you taking them? There's another grey area. Do you fail I know some firms are failing the portable Kemper type units because there's no air sampling. Do you pass them and say, well, caveat it out, you need air sampling to prove this? So there you've got, again, a pass, a fail, two different companies, two completely different outcomes, one upsetting the client potentially. Yeah. What's the thoughts on that for everyone?
I tend to pass with recommendations, put it in as a recommendation, and if obviously they don't continue to do that or don't do that at any point by the next visit, then you're then more inclined to say you could fail the system until it's proven that it's working correctly and isn't passing any of the contaminants back into the workplace. I think that's in my opinion, is the best bet. Like you mentioned before, Mark, about staying, working with your customers rather than working against them, I suppose, and just saying, you're doing this wrong and this is what you need to do. You're working with them to make it right.
So I have an issue with passing things with recommendations. In that, from my experience, people don't follow through the recommendations, or they might do it the day before you turn up on the next test, and in which time potentially you've exposed someone to a carcinogen for a whole year. If it's a guard on a machine and the guard is hanging off, they will stop you using that machine until it's put right. So why is LEV any different? If you fail the system, it doesn't mean they've got to stop using it. If you fail the system, it doesn't mean you can't help them and talk them through and advise them and help them to make it better. But what it does, to me, from what I've seen, it pulls them up. It makes them look at it and go, what do you mean it's failed? If you fail the system, they usually give it to someone to sort out. Whereas if you pass it, it tends to sit on a shelf until the next visit. That's just my view, my opinion. And, as Mark said at the beginning, Mark and I get great, but we disagree.
It's passing it with caveats, Adrian, isn't it? It's saying, well, you can continue to use it with other controls, with RPE. We're giving you a short time frame, which is say 3 months is what typically the HSE would use to get it right. If they get a visit from the HSE and they're not doing anything, they'll get an improvement notice. Then
but why not fail it with those caveats? You can still do all the same work.
I don't think personally you should be passing systems conditionally. Basically, This system controls if the items I've listed below are put into effect and rectified. I don't think you can do that. I think there are, and going back to something that was said earlier, I think it was Adrian might have said it, that there's far too many systems currently being passed that I see the reports and they clearly should not be passed. They should not be. We are passing far too many systems. Going back to something again, just following that Hazel said, I would commend you all to go and dig out after this the Health and Safety at Work Act, Section 6, and just look at it. It's the only really detailed part of the Health and Safety at Work Act. It's bullet pointed, and it's on suppliers, manufacturers, importers, designers. It's the duties on those people, very specific. It is in 2 blocks. Each block is mirrored. One block is for articles, such as LEV, and the other block is for substances, so people who would be supplying substances. Have a look at what it says people who import and supply articles should be doing. So that's all of you who are manufacturers and resellers. It is very clear the information that should be provided, and I think an awful lot of manufacturers and suppliers are breaching that requirement. HSE seem to be taking cases such as I've seen them and taking enforcement action against the duty holders, and that is the people who run the factories. And I did send an email to a lady inspector. She took a case and said, why didn't you look at Section 6? Because the installer had gone completely off rail here, and the designer, and she sent me a letter. She didn't reply by email. She sent me a letter saying the duty holder permitted that system to be used. So it does seem to me that HSE thrust is a little bit more towards the workshop owner rather than the supplier of the equipment. But I think time will come. Section 6. Now it's interesting that commissioning is not mentioned in the COSH regs or in the approved code of practice. It's not there. You think it's there under Section 7. It isn't. Regulation 7. It's actually under the poorer regs because LEV is a piece of work equipment. It's used at work. So the commissioning comes under there. So it is there. And we know that COSH regs are due for review. Brexit and COVID have both got in the way. They haven't even started reviewing. They've had a couple of interim meetings. It's unlikely to be reviewed and brought out as a discussion document for at least 2 to 3 years, in my view. But the word on the streets is that Regulation 6, risk assessments, and Regulation 7 will be fused closer to make it less easy to separate the two. And they're talking about bringing commissioning into Reg 7. So that's the future. And I think it's fundamental. If you're looking at an LEV system, in some cases, I don't think you can pass it or fail it without sight of the risk assessment. Because what was it there for? What was its purpose? Now, on simple systems, we can probably get around that. But a lot of the systems we do are much more complex. And I think without a risk assessment, here's an idea. We tend to say systems are satisfactory or unsatisfactory. Maybe we need to say not determined, because there's some information that's missing. We can't determine if it's satisfactory or unsatisfactory. Should we be saying not determined? Okay.
We tend to say unable to confirm control, and to be honest, quite rarely pass systems these days. If we put any recommendations in that's anything to do with control, we don't pass it. But I do find that the skill that I think you need most in this job is to be good with words, because I'm continually trying to look at how we put forward the information to the client, to give them the information that they need to keep on the right side of health and safety, and also to protect ourselves.
I think it is. It's client relationships. It has to be working with your clients. If there's a will from them to get it right, then yeah, you have to give them a little bit of slack, I think, and time to get things right. I think the heavy-handed approach, for us, that doesn't work. We prefer to take a slightly softer And yes, we're taking on a little bit of liability with that, I think, but it's back to wording. I think in reports we cover ourselves. We give the client time to get it right in a reasonable time frame, but not putting them at risk or operators at risk or others at risk. It's back to giving them a plan and getting an action plan in place that works for them as a client. It has to. Otherwise, you'll end up with no clients. I think for me, if you take the hardline approach all the time, yes, there's a time and a place for that if the client clearly isn't listening and doesn't have the will. But the majority of the time for the clients we've got, it's working with them, as you say, and just making sure you're phrasing it right so that they can make the improvements they need in the time frame that's suitable.
Just going back to the monitoring on the mobile systems, and obviously passing or failing or passing the recommendations. How would you go about testing for the gases that get through on the mobile systems? Because if you're doing your air monitoring for the metal constituents to see if anything's getting through, there's the gases that come into it. So are you ever going to pass the system? It's a mobile system. I would therefore say every mobile system is going to fail if they're doing welding fume, because that's a bit of a really grey area for me.
It's back to risk assessment, isn't it? It's what have they got? What are they doing? Is there a risk of that gas coming off? And have you measured it? Is there any data to back up? If there's no data, then it's back to what we were saying before. You can't determine that unit. You can't. It'll either go down as a not determined. You need additional information, or not satisfactory because for ozone or whatever it may be that's coming off.
You've also got the usage. I mean, I'm seeing more and more mobile units being used full time instead of fully installed systems. Which, if you're doing that, then there's more chance of gases building up in the working environment. I thought I read years ago that mobile and portable units should only be used for occasional works, for things like repairs and maintenance. But for the life of me, I can't find that document since. I don't know if anyone else has seen it or come across it. But I do agree. I think the portable mobile units and even the fixed systems for welding, you see them installed inside factories with filters which are good for the particulate element, but do absolutely nothing for the gases, and they just recirculate them. And when you speak to these companies, as I found out with one recently, they have no idea either. So I think you just got to recommend air monitoring. But as Mark says, everything goes back to the risk assessment. And we should be asking to see the risk assessment before we start the report, before we start the test. And if people can't provide it, say so in your report. Say there's no evidence of the risk assessment in the report. You've got to flag it. You've got to raise it with the customers. Otherwise, they don't know and they won't do anything about it.
But Adrian, it can become slightly problematic when you have mobile units. For instance, if you was to do an air monitoring on say, a device in a small workshop, and it failed, you could move that same mobile device out into a larger workshop, do some air monitoring. You may find that the values you get in a larger workshop are not as high. So you could have failed the small unit, you could have failed the unit in a small room, move it to a larger room, and it's okay. So it's the fact that these devices are portable that adds a different dimension to how the test has to be structured. And it isn't always, I don't think it's always a black and white decision. No,
it goes back to what I always said at the very beginning. We test what we see in front of us. You can't just go in and say, I'm going to test, that is it, black and white. You have to be more what's the right word, open-minded about it and what they're doing and how they're doing it. And yeah, using the right location, right circumstances, it could be fine. Using the wrong location, wrong circumstances, it may not work. On your reports, and I presume you guys all do it, you put the location of the system you're testing. And that's the reason why you put it, is because it has a bearing on the results.
And another element to add to that is I think we should be trying to determine an estimate of the arc time, because you can have a little workshop where the arc time is 2 minutes in an 8-hour period. In another workshop, the arc time is 6 hours in an 8-hour period. Now, how would we feel about a recirculating system in situation A and situation B? And then you look at these things which I hate, which they plug on to heavy goods vehicle exhaust discharges from the exhaust tailpipe, these portable recycling filters. And if you read the instructions on those, they very clearly say not more than so many minutes usage per day, and you know, engine size and so on. But those welding filter carts and come in various guises, you know, would we be expecting the manufacturers to say that there is a, you know, a limit on arc time that they should be used for? The other thing to watch out for with all welding fume, incidentally, it's usually the particulate that is the issue. I can understand that CO and ozone and so on can be an issue, but it's usually the manganese, the nickel, the chrome, the iron fume. These are the ones, particularly manganese. People say, you all know, of course, that although welding fume has been ascribed as causing an increase in cancer, it is not a carcinogen by definition. It cannot meet the CARC definition in the EH40, but the individual components within it can. So manganese is the one apparently that is regularly breached because it has a very low workplace exposure limit and can cause Parkinsonism. So the link is there. And you might say, well, there's no manganese in my steel, but there is in the consumables, and that's where we go over. And I've got great concern that some of these materials themselves may not be controlled and pass through filtration systems. But anyway, I've lost my train of thought now completely, so I'll shut up.
I'd just like to go back to a couple of points. I'm forgetting both of them now. Something Bill said, but also something Mark said when we're talking about passing and failing systems, and we were saying you shouldn't be passing systems with conditionals, and that's kind of where it comes into that whole control thing again. Because I've had a scenario, we've said you fail a system rather than giving it. Otherwise, they won't do anything about the issues. Now, I've had a particular instance, and I don't know whether this is all a lead up to what happened, but I do know that I tested a sack tipping hood, and the sack tipping hood was great. It was brilliant. You know, the flows on it were great when they tipped the bag, but they were taking the bags out and they had secondary contamination. And in that instance, I can't remember exactly, but I've got a feeling I've either failed it or I've said, I can't pass it, you've got secondary contamination. Quite possibly I'd failed it. Now I went back to that site the following year, they'd got a brand new tipping hood put in with a hood next to it, which still didn't solve the problem because they still had to take the bags out of this hood and put them into the one next to it. So still they didn't control the secondary contamination, but they'd spent a fortune on a brand new system, not realising that tipping hood did the tipping absolutely fine. The only thing they had to do is put in additional controls for the secondary. And again, it's those areas where you have got things wrong. And do you fail the system just to make them do something about it? If they're not understanding you saying, well, I'm unable to confirm control because you've got secondary contaminations, I think in most cases, to get around the issues that we've got, I think the only thing a lot of us can do is on these systems say we're unable to confirm. How can you pass a system based on the fact that you've got to say it's controlling if you've not got reference to a risk assessment on what other additional controls they have? Now, with a lot of work with the customer and a lot of understanding and getting those risk assessments and doing a lot more intense work, we can maybe get to those decisions. Again, it's something that ideally is done at commissioning, and we're just testing against commissioning, but we don't have that in the real world, and we're not going to get these testers out there. And the amount of LEV systems that need properly commissioning that are not properly commissioned at the moment, people doing LEV testing work are not at the level to do that commissioning and to be able to work with the customers and to make it worthwhile money-wise, to be able to go out and put that amount of effort in for maybe a £70 system or a £150 system even. It's not sort of realistic, and we're still trying to fit that, doing a test and proving control without the risk assessments, without the cost data. And the amount of systems I've seen, well over 1,000 systems, I would say 98% of them would have to be unable to confirm.
is there scope for looking at the way in which we report? I think Bill made the point far more eloquently than I was trying to earlier about the envelope of controls. But I always, the pass or fail always sits very, very uneasily with me, and where the LEV report is meant to be an assessment, if you read the guidance of the process and the controls, and to try and put more onus back onto the client itself, in which we say, yes, as far as we can see, that within the suite of controls, the LEV report is doing a job, but it's putting more onus back onto the customer, I suppose, back on about their cost assessment and risk assessment. Because of this, the whole kind of green and red, traffic light system of purely pass, in some way that's, as soon as they get a pass, that's them for the year. But having a report in which saying, yes, the system itself is fine, but you still need to, it's about trying to give them a yearly kick up the backside, at least, to say that, even if your LEV system is doing, you should be reviewing. It's going back into, I suppose, the regular review of the risk assessment.
See, do you not think, though, Kenneth, it's there ultimately to control a hazardous substance to a certain level? Either it's doing it or it's not. Everything else, is built around that. You have to make a decision for the client, be it welding fume, wood dust, flour dust, whatever it is. It's there to bring it down to a satisfactory level that is in accordance with their risk assessment.
Yes, absolutely. I think it goes back to the point is, a system can still be, if you look at say a wood dust system or something like that, something like a band resaw, you can, if somebody's using that wearing RPE, there's some LEV can only get down to a reasonable level, in the process, and they need additional points, and it's the same, the flip side of that as well. It's the pass or the fail sits quite uncomfortably with me sometimes when you're trying to give the customer a report, but it's all they look at is the pass or the fail, and
which leads
the recommendations for how they continually improve their controls, I think, is sometimes lost.
As an industry, are we missing the point here somewhat? We're there looking at one element of the control package in the LEV, when really what the customer needs and what they require is someone to check that they have control of the hazardous substance, and that could be a number of things to provide control, whether it be RPE, LEV, general ventilation, good working practice, user training. Should we not be developing the role of the LEV assessor into something, I don't know, control assessor or hazardous substance or environment control assessor?
But does this not go back to the commissioning, Adrian, to say, right, well, this LEV unit is working in conjunction with these other control measures?
Mark, it goes back further than that. It goes back to design.
That's back to caveat the LEV report, though, isn't it?
It goes back to risk assessment. But how often do you get a risk assessment from customers? Good blue chip customers don't always have risk assessments.
Then you can't pass a system. That would definitely be if there's no risk assessment, they haven't identified the hazardous substance, that's it. You can't go, how can you determine it's providing control if you don't know what it's controlling? There you go, it's a fail. I don't need to leave the office for that one. How often do we see that?
So what I'm saying is, okay, if these people need help, we're going to save lives. Do we need to go a step further? Instead of going in there with blinkers on and just looking at the LEV, do we need to go in there and look at the environment and say, we're going to assess the control of the environment here, not just that thing that sucks air out the room?
And this is back to what Catherine was on about to start with. It's the occupational hygienist versus the LEV tester, isn't it?
Yeah.
I think what we've done here is we've written off the job of a LEV tester, and what we now need is a COSH Reg 7 tester.
Yeah.
But what you can do is, if you're an LEV tester, and you have issues, you can say that one of the recommendations that you would make is that the risk assessment should be reviewed in light of your findings.
I think I'm much more comfortable with that. I think we try to take on too much responsibility sometimes. I think we have to try to go back. It would be good if we had something that, you know, some kind of generic document or something we could maybe use. That might be something we could develop and share. But just something that we can take back to the client to say, you know, back to fundamental principles. You know, you need to do this. It's not necessarily something every LEV tester is going to be able to offer, because their company might not have posh people or risk assessors or occupational hygienists. But the companies do need to understand what it is that they're responsible for, and they do need to do a proper risk assessment, and we don't always see that.
ATEX is another great example of this, I think.
It is, yeah.
We're expected more and more to comment on ATEX related issues on an LEV test. Yeah, and I think that highlights exactly what we're saying.
And that's going to become more so, as Bill says, when they review COSH and COSH and DESIR become amalgamated. It will be, you know, what is the DESIR element will have to be commented on in the same report. So that's not going to go away. That's only going to get become more and more of an issue. So as assessors of these systems, we need to be picking up on that. We need to be becoming competent in that.
I think this is just as Adrian says, I think you're absolutely right that these LEV testers do need to be occupational hygienists to properly test the system. But if we just work that forward and let's just say every single LEV tester in the country now is this occupational hygienist who can fully assess the system, we've just fully assessed every single LEV system in the country. Now are we going to pay the levels of an occupational hygienist to go back and reassess a system that you can send someone with confidence? I know that that system, you know, is able to control. All I need is somebody who can go and take some flow measurements and record them, do some visual assessments, compare against our initial intended data and check against the commissioning document. And then all of a sudden we've got all of these people that are competently occupational hygienists that we don't need anymore. We just need these systems fully commissioned properly and LEV testers to be able to do an LEV tester job, which is just to go and assess a system against a risk assessment and a commissioning data. The problem is we don't have the risk assessments and we don't have the commissioning data, and it's kind of like how to work that. It is the answer to get every single LEV tester in the country to a level where they can commission a system. Because to me, if it's commissioned and we've collected the data and we know it works properly, we just need to check it against that initial commissioning. And then all of a sudden, it's not the task it was. It's not a commissioning task, it's a retest task. So then we need our LEV testers again, and not occupational hygienists.
So I'm not promoting that LEV assessors become hygienists. They need a good understanding of occupational hygiene. So they need more than what they get on a P601 course. Okay. So I'm not looking for every person who tests LEV to be an occupational hygienist. That's not what I'm saying. They're different roles. But I think someone who assesses LEV must have more of an understanding of occupational hygiene and the effects that poor LEV has on people. Going back to the commissioning element, we can do a straw poll, but how many people go and test systems which haven't been commissioned? Or do you say, I'm sorry, I can't test that, it needs to be commissioned first? Because are we not making a rod for our own backs by testing systems that are not commissioned? And therefore, should we not be then saying, if it hasn't been commissioned, I can commission it for you and then move forward from there? Because you're right, Hazel. It should just be a simple testing, should be the easiest job in the world. It should be rocking up, looking at the commissioning report, asking if anything's changed, checking the logbook, ticking a few boxes. It should be dead easy. It's not. It's a minefield because of the state of the industry. Sorry, Melvin.
Sorry, Adrian. One of the problems you find is that most of the products that you will be testing or devices you will be testing have been supplied based on a product standard. And many product standards have no normative requirement to do a commissioning test. They have normative requirements to do a type test so that you have a profile of what this product can do, but they don't have any normative requirement to actually perform the test on site. Now, I've been arguing for, I've lost track of how many years. I always say, in my opinion, it should be the other way around. The more important place where you need to make sure this device works is where it's actually being used. So that should be where the normative requirement is. You must do this test on site to make sure that what you've got does the job. Now, when you look at the product standards where they put their CE marks or the new UK CA mark or the new UK NI mark on, they all stamp these products up as complying with a standard. When you read the document, when it gets to the test on site, there will be a tiny short paragraph that says, we recommend that you test this piece of equipment when it gets to its place of intended use. And in my opinion, that's where this needs to be beefed up more. We need to get more impetus on making sure that standards for the product contain at least, even if it's an informative annex, it contains enough information that somebody understands they need to get this commissioned before they put it into use.
I think some of this also depends on what angle you're coming from. You know, from my point of view, there's a lot of opportunities in this for businesses to grow and develop. And if that's something that you're interested in, you can end up being an expert in all of these things and be, you know, that can be part of your growth strategy. But not all companies want to do that. Some companies just want to test LEVs or just have a need to test LEVs. My concern is putting too much pressure and too much responsibility on an LEV tester. I do think we need to separate out the roles in some ways, and we do need to make sure the clients understand what they're responsible for. And well, it's not our responsibility to let them know what we're responsible for, but if we don't ensure that we've got that initial data, somebody's got to do it. Either the client's got to take it away and get it done with other companies or other contractors, or we've got to do it for them, or we've got to state that it needs doing. But I do feel very uncomfortable about, you know, I think we're here, I think most of us are here because we want to see the sector improve, and I am very uncomfortable about putting a huge amount of responsibility on an LEV tester. I'm not saying that all these things don't need doing, they do, but it's not an LEV tester's role to do some of the things that we're talking about. We do need to make sure those things are in place, and I do think it is, sometimes it needs to be somebody else's responsibility.
Now, you come in from the beginning, you have a risk assessment that determines if further controls needed or what controls needed. Then we get things like benchmarking, then we get design, then we get installation, then we get commissioning. Then along comes a tester. Now, if he hasn't got the previous bits, the risk assessment, the benchmark, the design information, or the commissioning information at least, how can you ask that tester to go and do it other than straightforward system? I don't see that they can. And that's the issue we have now. So actually, it's further up the food chain from the LEV tester that we perhaps need to be focusing on, yeah. Even before design, Adrian, right through to risk assessment from the client.
Yeah, I think there is a...
So it goes back to what we said earlier, is it education of clients?
I mean, well, could it be that the testers ask for the client to provide them with the commissioning data and provide them with a benchmark before they would agree to go to site and perform a test? Could all testers ask for those three things and say, I can't come to site unless I have those three things sent to me before I make an appointment to visit you?
Commercial suicide, Melvin.
That's what we come back to. If we want to get something done, it's got to be done unilaterally by everybody, and it won't happen because there'll always be somebody who'll say, "Well, I don't care. I just need that job. I'm going to go and do the test."
That's exactly it. I went to a job last week, and I was just I was so surprised because the test was only done last last August by quite a well-known LEV company. 20 systems, 2-page reports, all of them bar one passed. The one that failed clearly failed. And the reports were absolutely atrocious. There was hardly any detail. I went to the site and I saw the systems, and there's no way those systems should have passed. And it just sickens me. It's just from the concern for the workers that are working in those environments. So you will always get that if there isn't something kind of more stringent put in place. You will get companies that will just say, yes, we'll come and do the job, and we're not bothered about seeing all that other stuff.
I know that many of you have had situations where you've done proper testing, carried out proper testing, you've failed a lot of systems, then you find you're not being re-engaged to do that client again. And they've simply gone out and engaged someone who will give them the reports 2-page, 1-page, that gives them a pass. One of the things maybe this group can consider, how can we cut the leg off these people who will do very inappropriate testing at silly prices, because they're undermining the good work of the better people. And I don't know how we can stop it.
Yeah, I'm just
also, how do we help us? Sorry. How do we help those companies? Go on, Hazel.
No, I'm just saying on Bill's point, do we need some sort of something in place to say we need this standard from an LEV test? Because Catherine's absolutely right, there's too many still out there that's a couple of pages and they're stating that they're passing. So we need to get that clearly out there that there's a big problem with this pass-fail thing, and we need to put something in place to relieve that. But maybe we get some guidance out there that is saying, if there's no cost risk assessment seen, if there's no manual and logbook seen, if there's no commissioning report, it's just a clear fail. Why don't we just put that standard in place, and then it cuts that problem out completely? Because how do you pass a system without those documents? And maybe every LEV tester, because like Bill said about commercial suicide, there's too many companies out there that are doing LEV testing. We can't just go, right, bang, we can't do this anymore. An LEV tester can go in and do an LEV test. If he hasn't got manual, he hasn't got a logbook, he hasn't got a commissioning report, he's not seen a risk assessment, you can ask and ask and ask and ask, but you won't get them. Why don't we just make it a standard that you do not do an LEV test without asking for those documents, and you cannot pass a system without seeing them? And then it just throws it straight back. And then these companies are forced to keep the systems properly commissioned. My only concern is I don't think there's enough people at the level of being able to do commissioning, because I'm finding a lot of companies saying to me, what shall I do? I want my systems testing to a good standard. I know they're not being tested to a good standard. Where can I go? And to be honest, I'm struggling to tell them where to go. I feel uncomfortable.
Those standards are out there.
Still, to be honest, I feel very uncomfortable because of all these grey areas, and I don't know which direction to point these people into. And there's a lot of people coming on courses now that are saying we're coming on the courses because we're struggling to find someone to test our systems properly, so we want to learn how to test ourselves. And I'm starting to see quite.
And then they probably find that doesn't give them the information that they really need.
No.
The standards are out there. ILEVE, we have the standardized report form, which asks in the first few questions about commissioning documents and risk assessments and desire assessments. We have a commissioning guidance document which is out there. It's freely available to anybody who wants to go and download it. We've been promoting it for years. We have the competency scheme. We have a competency matrix which talks about all this and covers all this and what people should know. The industry doesn't want to sign up.
Adrian, it's not a question of the information being there. I think it's the uptake. People are just not doing it. I think
they're not.
Most people who are doing testing, if you ask for the commission report, I'm guessing 80% of the time there is no commission report. No. And the remainder, when there is a commission report, is very thin. It's a one-pager. We had instance recently in the Northeast where somebody that we know is doing one-page commission reports. That can't be a commission report. So in many cases, many cases, the LEV tester isn't going to have a commission report.
No.
But
quite often.
if that's the case, doesn't the LEV tester have to do an initial appraisal, which in effect is retrospective commissioning?
It is,
Yes,
indeed,
yeah.
absolutely.
So are we doing that?
But that's not what HSG 258 states. That's HSG 258 334 says where the information is available, the tester should use it. Being a good lawyer, you can just say, if it's not available, that doesn't say I can't test that system. Now, I'm not saying that's right, because
no, but I think the point that's being made, Craig, is that if you go along, let's say a client engages you to do routine testing, and you take over from a previous contractor that's moved on, and you've got the contract. So the contract is to do routine testing, and you go in, and there's no commissioning report at all, and then you look at the initial, and the initial is a 2-pager. I think it's incumbent upon you to say to the client, we need to do a full, thorough initial again, because that will, to some extent, take the place of the missing commissioning report. I mean, years have gone by, so it may not be performing exactly as it was when it was installed, but it's the only thing you can do. And I spoke to HSE about this and said, is that how you view it? And they said, yes, but we want like an initial report plus. And I said, what do you mean plus? Because initial report is quite important. But then they went on to explain one or two other things that I thought were a bit picky, but they were talking about physically measuring fan current, physically measuring fan speed, making sure that when you do duct traverses, you use the equal area method as you would at commissioning, which people don't do at commissioning. So basically, an initial thorough examination report, maybe with some view to what is missing from it, from what should be in a commissioning report. You know, that's maybe what we should be looking for. And let's face it, a commissioning report, and indeed, if we want to go on what Hazel was saying, manuals and logbooks, it's the one bit of HSG 258, and I can tell you it's page 80. It's very detailed, it's bullet pointed of exactly, generic, fair enough, but exactly what should be in a commissioning report. So if you look at your initial, and then look at that page 80 for the commissioner report and say, right, what extras do I need to put in that I can put in? Then it would be a sensible approach to take. And you can say that in your initial, saying that this initial has been prepared in the absence of any commissioning data, and that it can be used, for example, in lieu of it, to prepare the manual and logbooks, which will be missing as well. If there's no commissioning report, there'll almost certainly be no manuals and no logbooks.
Well, that's what I mean.
And there's no get out, incidentally, Craig. There's no get out. If the system's been in for 12 years, it still has to have a manual and logbook.
But that's what I mean. If HSG guidance document says if information is available, then use it. If not, just make sure do with what you've got is basically what HSG 258 says, where it should say if that information is not available, you cannot do the test.
I think there's an acceptance within HSE that HSG 258 is a little bit beyond its sell-by date, but there's no resources, there's no plans that I'm aware of to review it. I think it really could do with a thorough review. And there's a lot more people, such as the people on these screens. There's a lot more people now who could give a lot more practical input to a revision of HSG 258. Adrian, maybe that's something ILEVE could press, is to speak to HSE and say, we really think HSG 258 could do with a dust off and an overhaul, because I think it is, bear in mind, it's 15 or more years ago when it was introduced, and we've all learned and improved an awful lot since then.
I think they need to do a series with HSG 258, so like supporting documents in certain fields like welding, just make it clear once and for all what should designers be doing, what should LEV testers be doing, to make sure that everything is satisfactory.
You're not going to get that, Louise, because now, I mean, the way forward with HSE is they're not going to give you specifics anymore. It's generalities. They haven't got the resources themselves to either write and, more importantly, keep these things up to date. There is no will within HSE to do that.
Louise, the design of things like welding fume extract systems, they're not difficult. It's not rocket science.
Yeah, but we see so many bad systems.
The problem we have isn't the design of the systems, it's the mis-selling. It's people selling things on the wrong application because it's cheap and easy to do so. Or it's poor buying, people not understanding what they're buying. You know, if you look at movable capture hoods, which we all love, they're massive in their different variety and the ranges you get, from 200mm hoods, which will give you good control, good suction in a lot of applications, down to 50mm diameter hoods, which Melvin was saying they're using the pharmaceutical, and even smaller, can't you get down to sort of 32mm diameter hoods, which have virtually no capture. It's putting the right system in the right application, and there's an awful lot of mis-selling in the LEV industry. And you know, how do we stop that? That's another conversation in another probably day or two to take up. But that happens, and the people we need to talk to stop that aren't part of these forums. They're not on these calls. They don't attend the conferences. They don't partake in any of this because they don't want to know. They're too busy out there selling stuff from their catalogs. You can buy stuff on the internet.
Very often, I'm asked to go to a project, and they say we need our fume cupboard testing in accordance with EN 14175. So I perform the test, but I always make a point of telling them after I've performed the test that all you have now is a list of data on your fume cupboard. It's not a thorough examination of your whole fume exhaust system from the fume cupboard to discharge. And I say, you now need to go to get an LEV engineer to do the rest of the check, then give them our report for your fume cupboard, which they can then use as part of their thorough examination report. It's about people accepting that you may not know everything, but you can contribute to the whole as long as people know where to go and get that advice.
Yeah, I've got exactly the same issue at the site that I'm at, and it's exactly what you just said, in the fact that, you know, the site is not compliant in terms of doing a whole thorough examination of the LEV system, because there's been lack of knowledge on site, and that the belief is that because they're doing the fume cupboards and safety cabinets testing where the users are, that's been sufficient enough. When that's not, you're not testing your LEV, you're just testing that air capture device, and that is all. You're not testing the whole system from start to finish till it goes out the building.
Yeah, it's a brilliant point as well. And another thing where I think a lot of LEV testers get confused, because we talk about the British standard of testing and we test as found with the doors and windows closed. Well, yeah, with the doors and windows closed, we can compare maybe against that type testing. But if they're using it with windows open and they're using it with doors opening and closing, your LEV test has to take into account of them, because we're testing for control. So we don't want to test with windows and doors closed. I'm kind of like, we take our measurements with windows and doors closed to compare those measurements against what it should do, what it's manufactured to do. But the LEV test is about the controls. So actually we need to know what's happening at the time of the test. How is it used? Do they have windows and doors open, closed? And again, I've seen so many LEV test reports that just take phase velocity readings and they don't look at the discharge points. That's one of the biggest problems that I've come across. I think that comes back to sort of, again, the LEV tests not being done to the standard that they need to be done, and there are still a lot out there that are not being tested properly.
Stuart, what we're finding on big sites like yours are that the test that's been undertaken is what you've historically been doing for the last 20 years. Nobody can actually answer why you were doing it that way in the first place.
Yeah.
Commissioning documents.
Yeah.
You go on these big sites and say, well, we want 10 meters per second at this hood. And you say, well, why? And nobody can answer that question. And the engineer that instructed that 20 years ago has left, and left with legacy issues.
Yeah, that's kind of exactly what I've had to pick up on. You know, I've recently joined there. With all this sort of new information and knowledge that's just never ever been there, and it's just been neglected. purely because of a lack of knowledge. And like you say, there's been no one to question it and say, you know, this is not good enough. And you know, hopefully that will change within the coming year that I'll be here on site. So.
And this comes back to, I guess, sites like yours it's where it highlights the COSH assessments and air sampling and things like that become a lot more prevalent, a lot more important.
Yeah, and the only other issues as well that I've recently found since I've started there is that because of the design of the system, it makes it hard to do a complete thorough examination test of the LEV system, because the whole building is connected as one system. So it's pulling fume cupboards from, you know, hundreds of labs all going out the same stack on top of the building. So it's a case of, you know, how would you go about testing a system like that when you've got hundreds of fume cupboards and safety cabinets all linked to the same LEV system going out one stack at the building across multiple floors?
Which is also normally connected to the air handling unit and the central vacuum as well.
Well, yeah, I think the supply air is separate. That'll have its own HVAC system from what I've gathered so far. But certainly the general extract out the building is shared with the LEV from fume cupboards, and it's you know, I don't think that's ever been considered in terms of, you know, is there other factors as well that, you know, filtration before you can point out the stacks, and you're mixing it with powders and fumes, and like I say, it's just lack of knowledge about LEV systems, which I think has never been there.
Yeah.
Also on installations like you have, Stuart, there's often diversity that's inbuilt into the design, and variable air volume control. And that adds another dimension into how the test becomes difficult to do, because the user has to be aware of that diversity, and they also have to be aware about where variable air volume control can affect it, because many fume cupboards will contain, even with velocities down at 0.3 meters per second. But what happens is, once somebody starts to interact with that device, move in and out and away from it, you get breakout of the fume, and it takes that 0.3 meters per second twice as long as it would take 0.4, 0.5 meters per second to recapture and stabilize itself. So you are right. It does become difficult, because when you're doing the testing, you have to look at the whole building and try and work out how you can effectively work on each floor, perform your test without obviously prejudicing the work that's going on the floors above.
Yeah, and that's it's still. I mean, it started there in October, and that's, you know, one of my first things that I picked up on is obviously, one, they're not doing the LEV systems as a whole, or never, you know, not done any thorough examinations, and obviously how on earth they're going to do that, purely because, you know, essentially you'd have to check every lab, every floor in one go, which you'd need hundreds of LEV engineers to do it all at once, and it's just not feasible. So, and again, obviously, you know, that people can be moving things about, opening and closing fume cupboards, and dampers adjusting while you're doing it. So it's the case of, you know, how would you even begin to do a test that large? And, you know, the only kind of feasible way I can see it being done in my head at the moment in time is you'd have to possibly just do each lab one at a time per lab as a report, and then collectively put them reports together somehow to get a full overview of the whole building. But it's a tough one.
My thoughts on that one is that, frequency would probably have to increase as well, not just doing it annually, but increase the frequency to try and minimize that risk for potential of lack of control or loss of control due to some other factor. So the more you're testing it, the higher frequency, you're not going to eliminate it, but you're reducing the potential of the risk there as well.
Yeah. So we are doing the 6 and the annual monthly tests at the on the capture devices and fume hoods and safety cabinets. But you know, another factor is that, you know, under obviously they need to be doing weekly inspections, which I think again has never been done. And again, to implement something like that is, you know, there's thousands of assets across the site that are attached to LEV systems. So if you wanted to do a weekly inspection of all of them, it's another 4 or 5 men just to be doing that every week, going round looping and looping and looping.
Stuart, do you have wind responsive discharge stacks where you are, or are they just standard?
I couldn't tell you at the moment in time. I don't really know. I've not really had much chance to get up to sort of where the stacks are, but
Okay.
I believe it's just there's a bank of, let's say, 8 fans, and obviously they'll adjust depending on the demand of what's being used throughout the building.
Without going down a rabbit hole and picking Stuart's system to bits.
I think you did that himself, Adrian.
Classic example of a big complex system, which if we're going to go and test is going to take tons of man hours to go and take all the various readings. I've often thought, when I was used to do building services and look at boiler systems, we'd have low pressure hot water systems, and you can't put a pitot tube in them and measure them. You'd have a pressure gauge on, and you just monitor the pressure gauges. Why are we not putting fixed pressure gauges on systems across fans, across filters, across certain points in the ducting? So, we talk about measuring static pressure, take one reading in the pipe and the rest of it. Why don't we have a gauge fitted there permanently so we can just go and look at it? And that way, that will make these tests so much more simpler. Do we need, if you put a gauge on something, you can then link it back to a control system. You can have remote monitoring. So Stuart,
doubling up those results basically.
You could have the results ping through to you onto a spreadsheet, onto a website, where you can just dial in and monitor it. We need to look at the bigger picture with these systems. I know we're talking about testing, but there's also people on here who design systems. And we should be, we've talked about it several times, the designs are poor with LEV systems. We need to be going back to that design stage and making sure they're right and improving the standards. That will make testing simpler and better.
Yeah, I mean, one of my arguments as well was, there's obviously going to be a lot of projects works that they carry out on the site. One of the comments I made was, instead of trying to put everything through the same stack or the same bank of fans, it's probably a good idea to start considering any newer laboratories that they're doing up is they make them independent, because it's going to make control and testing and designing much more simpler when you're coming to do your tests and your examinations. But again, it comes down to it costs and practicalities and limitations, which obviously can be a struggle to argue the case.
I think you hit the nail on the head. It's cost, and it's not so much cost retrospectively, cost at the initial outlay time. When people are buying these systems, the capital cost, the capital expenditure is always driven down. So therefore, you don't get any bells and whistles. You don't get any frills with it. People are going for the cheap option because it's just extraction. It just sucks. Why do they do that? Because of lack of education to understand, actually, you need to have control.
Yeah.
These systems are critical in that they keep people alive. They stop people getting horrible diseases, and yet we scrimp on them. So how do we change that view of LEV? How do we get people to appreciate what it is? Don't know.
Yeah, totally agree. It's trying to get people to understand that it's more than just extract.
That brought the tone down, didn't it? It's all gone silent. Well, that happy, cheery note, yay!
Everyone's contacting Stuart to see if they can work on his site. That's why.
Busy. Sounds like you've got your work cut out, Stuart.
Yeah, well, it's funny, that you say that.
I think
I was having I think, you know, I was having a couple of messages on with Adrian on LinkedIn, the fact that they used to be LEV engineers on site. Well, they classed themselves as LEV engineers, but you know, they no longer work there, and were forced to have contractors on site to be doing the fume cupboards and safety cabinet testing, and obviously trying to hire new people and train them up and get a better quality and standard of testing on site. But you know, trying to put all the new methods and in place and making sure things are right. And like you said, that's been mentioned already, is there's lack of, you know, risk assessments and commissioning data. Everything that's been covered is just a lack of it. And you wouldn't think that in this day and age, especially for a large company as it is.
Well, it's easy for you, Stuart. All you do is you set all your fume cupboard performances at 0.01 ppm, because the method of detection and the procedure to perform that testing, you can only the best you will ever get is 0.01 ppm. So if you're in doubt, just set 0.01 ppm and then just wait people running around to try and find it. It works.
Yeah.
If you follow the EN 14175, if you follow the test procedure, use the detection equipment, and also you use the method of doing the calculation and presenting the results, the best number you will ever see on your report is 0.01 ppm. That will always be the best number you will see on your report. So if ever you're in doubt, just ask for 0.01 ppm and then let people speak to you about what they're going to do about it.
Yeah.
We've got quite a lot of end users in the group as well. Is there any questions? You've got designers, testers, occupational hygienists online. Anyone got any questions? No. That's maybe one of the issues we've got. Purchasers and sites not asking enough questions, maybe.
I've got to go, but thank you very much. It was lovely to see you all again, and I thought it was really useful.
It's good to see my sister in months.
Bye, Hazel.
See you, Catherine.
Thank you for joining us. See
Bye,
you.
Catherine.
Bye.
See you, Catherine.
Cheers, Catherine. Bye-bye.
Right.
I think one positive to take out of this is the fact that everyone in here wants to do better, whether you work for a company, whether you're a tester, an occupational hygienist, or you own and run a company. There's a positive that we're all wanting to go in the same direction and up the standards and the levels of what's going on in the industry. I can't say that for everybody else in the industry, of course, because there are companies out there that aren't willing to learn and progress and move forward. So fair play to everyone who's in here now that want to all move in the same direction.
Yeah, we're probably already talking to the converted. You know, we're not perfect, but we are trying to do the best and educate and get the best out of the industry. So we're probably not reaching the people that we need to reach, really.
Yeah, that's the point, I think, Louise, that, you know, those that are on this call today are aware of what the issues are. They're also aware of probably some of the remedies, but it's getting the wider audience to listen in. I don't know. Perhaps we could do a huge seminar and just have all these same faces on there. Just let people listen in for an hour, just to see what goes on, and try and perhaps get a better feel for how difficult it is for the LEV engineer, unless he's supported by those that are actually asking him to do the work.
I think we're also. Oh, sorry.
Because if I could make a little point, I'm really new to the industry. I've been only in it for about a year now, and working in the contract and installation side. And it seems like the LEV testing installation is seen as two really different roles in a company, and you don't really get as much insight into the other side of the table. So integrating the two a bit more, working almost left like two different things would be quite useful for installers. Do you see what I mean?
Yeah, a company that can install, design, and be able to test it is kind of like what you want ideally.
But on the other hand, that's something we offer. But on the other hand, we're not very keen on promoting LEV testing our own designs, because then, although we're obviously very professional and we will test properly and we'll go through snag lists and correct them because we want that quality, there's, with some companies, there's a pass kind of culture. They can't possibly fail it because it might upset the boss.
I think what I probably more meant was like the installers seem to talk amongst themselves, the testers talk amongst themselves, and there's not as much collaboration as in making sure the installer's doing something that the testers think is right for them. That makes sense.
I think groups like this really help, Oliver. I mean, the guys on here, we've known each other for quite a while now, and we do ping each other questions and ask questions, that we're, related to systems that you might not understand. So yeah, but I think this is a great thing with the LEV Central Group, and not being afraid to ask those questions. Yeah,
and getting more installers into it, try and force them to listen to it.
Yes.
I think that feedback loop is really important, because if you are installing, you need to know each other's requirements. And I have found that when a system's installed, particularly things like food sites or pharmaceutical sites, ideally those test points need to be in that ductwork before it's put into place on the site. Because if you install a system, they start putting product through, they're not going to let you drill a hole in it. So when these installations go in, they need to be installed so that they can be tested, and it's getting that communication between the two. If you're an installer, understanding what the requirements of the tester is going to be once it's installed.
Or in our case, getting the test point in the right bloody place.
Yeah.
You can ask for test points and you get to site, you're like, oh God.
Yeah, well, I used to go around with a marker pen for the customers and say it needs to be here, because they wouldn't allow us to do it. I'd say, well, that's okay, as long as you get it done, this is where they need to be. Go around with a marker pen. Yeah, that's a biggie.
Gareth, going back to what you were saying earlier, though, I think you're right in that there's a lot of people not on this group, but our view certainly is that if we just keep getting better and better, they'll either raise their standards, they'll be forced to, or they'll fall out of the industry, which is what we want for some of them at the bottom. I think that's all we can do, is just keep striving to get better and better with it. Through collaborations like this, that definitely helps.
We haven't got to lose sight as well that as an industry, we've come a long way in the last 10, 12, 15 years. I mean, Bill, when you started doing 601 back in 2005, 2006, I mean, before then there wasn't very much, and now we have lots of people who have some qualifications, who have more awareness. We are raising the bar. There's more guidance out there now than there ever has been. There's help and support in places like BISA. There's the documents such as TR40 available. There's a wealth of stuff on the internet, none of which was there before. So it is getting better. It's just, we want it to go a lot further. It will take time, and we just need to keep chipping away at it as an industry.
Thing is, nobody's perfect, and each individual on here, the companies you work for and yourselves, we're not all going to be doing everything perfect at any one time. And as long as we can all strive to move forward and do that, and aim to bring your company up to a standard and bring each individual up, then obviously that's the main aim, isn't it, really? It's
the consistency, like Hazel was saying earlier. It's where you haven't got a risk assessment, we all agree that's a fail. It's a fail or a not determined. You can't pass a system without identifying the hazardous substances. So it's things like that. It's getting that consistency across the group, so that we go from there. That it has to be that way, I think.
Can I just ask Adrian, are there any sort of movements forward about looking at maybe some sort of way of having an apprenticeship scheme for LEV or something like that? Because I know that is another issue where we've got a lot of LEV test companies that are not getting it right. We've got newbies coming into it and they're doing the P601, but they're working for these companies that really they're not getting the influence that they need. Have we got some way of an overall, other than just the P601, P602, of kind of getting these engineers trained up?
So yes, in answer to your question, there is the ILEVE competency scheme. competency card, which talks about what people need to do, what competency looks like, and they can apply for. ILEVE has also spoken to BISA about bringing in apprenticeships. Now that means the BOHS P series qualifications need to be aligned with the NOS, the National Occupational Standards, which unfortunately they're not. So we're in the process of getting that aligned. Once that is done, then BISA will be able to set up apprenticeships for LEV work. But you are looking at years,
right,
before that's done, unless anybody else wants to volunteer and help out.
I'm quite happy to be involved.
So yes and no. Yes, it is being looked at. It is happening, but like all these things, it will take time.
Yeah.
Because we just need more people to come forward and help do that.
Right.
We go back to recirculating units, if in the absence of anything else from anyone else, and just see what people's thoughts are on those. How are you testing them? Are you testing them with a handheld? Are you doing air sampling? Or say for the portable welding units, for example?
Well, I'll do a visual. I'll pull the filters out first, check that the clean side is clean, and then I'll put it all back together. And on the outlet, I use just a handheld Casella Microdust Pro, or I've got a piece of kit that I got from Bill that's wonderful as well, and just see if there's any particular, when they're welding, coming through. But it needs to be when they're welding. I've seen LEV testers on site. They're using these particle counters, but the process isn't happening, so there's no particulate being handled by the filter, so you're not getting a real-time snapshot of what's going on.
Louise, do these Casella instruments need setting up originally for what the particulate is?
Not the one I've got.
It's purely indicative, Hazel, and this is the issue we've got. It's just, if you go back to the ACOP, it's non-specific. It's air sampling at the recirculatory exhaust outlet. What does that mean? Checking concentrations. So I guess it's, you're looking for breakthrough, evidence of breakthrough, and that's all you can do, isn't it? It's just an indication compared to background levels for us.
Yeah, I'm kind of at a loss on this one, because in terms of the cost regulations and then the guidance in there, it states that there should be information available with respect to an LEV on the efficiency of the filter and any contaminant coming through. But it's that age-old, I talked a lot about the visual observations. To me, a visual observation isn't enough. And I'm kind of getting the message, I don't know if other people are getting the message, that as an LEV tester, you use a dust lamp or a smoke test for a visual observation. However, at a filter, if it's recirculating, all of a sudden we need sampling data. So why do we need sampling data at the outlet but not at the inlet, at the hood, and vice versa? Should we have sampling at the inlet as well as at the outlet? And we've got, again, one of those big grey areas. What should we be doing? In terms of just reading in the regulation, it does say about the concentration of contaminant in the exhaust air. It's not particularly listed in the elements of the LEV test. It just says what should be available in respect to it. So it's not clear, does it have to be done at every test? And what do people think about, well, we're saying we only need visuals at the hood, where you've got more chance of getting exposed. However, do we need sampling and some sort of sampler at the outlet? I'm a bit sort of confused over those ones, and what do other people think?
We've done some tests recently. I did some looking at using a dust track and some portable extractors, brand new portable extractors we had in our stores. And I tried it first of all with smoke, and it was getting very, very high readings coming out the exhaust. My problem was I didn't know what concentration was going in at the first place. I then got one of our engineers to carry out some welding on a brand new system, and I was getting about 13 milligrams out of the exhaust, which was quite scary.
Yeah.
In an ideal situation, and it's going back to what Melvin was saying about having a known concentration going into your hood to try and see what the, to measure efficiency of the filter is really about trying to see what's going in and what's come back out. And, I thought at first I could perhaps use, when I use a smoke machine, when I use one of the little mini pea soup ones, it doesn't last, it's the sort of quick dispersing. I think the smoke is broken up in the filter. If I use one of the larger units we use for doing clearance tests, the smoke comes straight out the exhaust. When I test with weld fume, a large amount is coming out as well. So it's so difficult to try and actually gauge in the real world. And I was, well, that's a brand new filter. I don't know whether over time, if that filter was pre-coated or had been in use for some time, whether the efficiency would get better.
So testing filters in situ, there are standards, especially for HEPA filters. There's the ISO standards, which we should be doing. And I know we're not, as an industry we're not, because the test kit is so bloody expensive that none of us would get any work if we did it. I think it is more popular in the sort of recirculating fume covered industry, which Melvin can probably tell us more about. But for your weld fume units, to control the smoke, they should be having sort of HEPA level filtration. So should we be doing the ISO standard HEPA filter test to challenge that filter, not just the filter, but the sealing and the seating of the filter as well? But then will customers pay the £500,000, £600,000, £700,000, whatever it's going to cost per filter to do that test? No. Do we need some guidance as an industry on what we do to test these filters? So I do believe the SEC has concerns about it, hence why they put the post out there to look at recirculating filters.
Sorry to interrupt you, Adrian. I just wanted to say goodbye to everyone. I'll have to shoot off now. Got a meeting, but thanks for everybody's time. Appreciate everyone's input.
Bye, Gareth.
Hey, Gareth.
Cheers, Gareth.
Gareth.
Thanks.
Just to pick up on something that Hazel said earlier, a lot of people are using a TSI Dust Track or the Casella Microdust Pro. These units have a calibration tube that goes into it, so you can calibrate it each time before you use it. What people don't realize, it's calibrated on Arizona road dust, whatever the heck that is, and it does say that you're supposed to calibrate it on the typical dusts that you will be dealing with. Of course, then that becomes a problem for LEV testers, that every system and every client they go to, it's a different material. So they can only ever be indicative. I think the problem I see is that there is a very small percentage of recirculating filters that are actually being tested at the initial or routine thorough examination test. And I would like to see at least something started across the board where people do something on these recirculating filters, because the majority are not doing anything. I know you guys are probably doing something as you go round. The other thing that Adrian mentions, the DOP testing, I think the problem might be the access to be able to carry it out in the way in which it's currently set out in the standard. And therefore we would need to try and maybe amend it and adjust it to suit the type of situations that we might come in. And then we move to the one that's in Melvin's area, is the carbon filtration on recirculating fume cupboards is just not being done. Very, very few people are doing it, yet it ought to be done. Mark and I were involved in a situation where a guy was doing testing, nothing to do with us. He was doing the testing on a recirculating filter, and he spoke to us and said, what should my protocol be for testing? And I think this is something we should all do, and we should all do it more frequently. I said, go back to the manufacturer, ask them for the protocol, put down that you've actually asked the manufacturer for the protocol. For goodness sake, if the manufacturer can't give you the protocol for testing, who can? The manufacturer in this particular case come back and said, oh, you'll smell it before it's of any problem. we passed that one to HSE. So we do need to think about what we are doing, and we need to do something, and not just for the particulate one, which I know is an issue in welding and the gases, but also in laboratories where these small recirculating fume cupboards are used quite frequently. Incidentally, I don't think you'll get a guidance standard from HSE anytime soon. I think they've been gathering information, but I just think everything's been pushed back and back. So I don't think there'll be anything soon. But they did say to me, but we do expect them to be doing something and to be able to demonstrate to us the basis on which they're doing that test. It's kind of, and that's very typical of guidance these days. It's basically over to you. We want you to do something. Show us what you're doing, but justify why you're doing it in that way.
Can I just ask everybody's opinions on these wood dust systems, these internal sort of recirculating sock filters? Because again, it's an asthmagen, wood dust, potential of cancer as well. And we've got these recirculating systems. And currently, the only guidance, there used to be a lot of guidance for wood dust systems. The only two left, 23 and 32, I think it is, all talk about these sock filters. So can we pass them? Do we have to fill them? Because they do let the respirable dust through. I think we've seen that already. What do people think?
Louise has sent me some fun photographs of using a particle counter when they've been switched on. You want to comment on that, Louise?
Oh yeah, the dust passing through is through the roof. I'll post it on the LEV Central Group. It's using, is it the HT900, Bill? The
very cheap, nasty, disposable Chinese thing, which is better than nothing, but it's got a little bar that it gives you an indication.
Like
You've got
a
to be
traffic
very
light.
Yeah, you got to be very careful. It gives an indication in micrograms. So if I run it in my office here, it'll tell me I've got 24, and it isn't milligram per meter cubed, it's micrograms. So you have to divide it by 1,000. But there's a little bar at the top, which is traffic light color. And Louise sent me some pictures where the little cursor goes off scale when you switch them on.
Yes, yeah. And that was when it first balloons up, so it kind of puffs it all out, doesn't it?
Yeah. I mean, to be fair, it might well settle after that, but it does show that the respirable dust. Just happen to have one here. Don't know if it'll fire up. If anybody can see, it's a cheap little device. And you can see the color bar. Oops, I've got my camera the wrong way. You can see the color bar on the top and the little cursor going across. And it's simply just an on-off run. You can't calibrate them. I spoke to HSE about them. I'll actually start it running, and they said that's fine as long as you make it absolutely abundantly clear that it's an indicative it's an indicative test that you're doing. I don't know if it'll focus, but it's actually showing a countdown in seconds at the bottom, and it will eventually give me oh, there it goes, an interim reading. I can't see it in reverse. It's 63. It's got very dusty, so it's 0.063 in my office at the moment, or plus or minus 20% to say. But you can see that the actual cursor started coming off the green. Now, when Louise used something like this, I don't know, Louise, it gave you something like 57,342, and that cursor went off scale. So that's the kind of the recirculating positive sock filters.
20,102 on PM10.
Oh, there you go. You've got to divide it by 1,000, but it's still 20 milligram per meter cube, Louise. So, yeah.
I think going back to the question, when you're using those hanging bag sock filter units, what is reasonably practical? If it has to be reduced by a LARP, if you've got a factory, a workshop, which has an investment, and they're putting in a system which is there to stop someone getting a life-threatening disease like asthma or cancer, is it reasonably practical for them to put in a system that works and doesn't put research dust back into the working environment? When you're looking at the long-term picture, these units, unfortunately, a lot of people buy them on short-term returns, when in fact they should be purchased over a 5, 10, 15-year purchase. So I think you can argue that it's reasonably practical to put in the right type of system and not a hanging sock unit on fine dust. If they're used on chippings and shavings, probably not a problem. But if they're on fine sawdust, personally, I don't think I've ever passed one yet.
Would you put the same argument forward for the welding, the portable welding fume units, then, Adrian, as well, on that basis?
Yeah, very much so, Mark.
See, it's back to it's ALARP, and you're stepping into the definition of ALARP and you're defining it for the client, aren't you? It's got to come from them, really. That's the issue. You can nudge them in the right direction and say, you know, based on what we see, we don't feel you should be using that. But it's ALARP, and it's that unknown quantity of, you know, what's reasonably practicable for one isn't necessarily the same for another.
No, you're right. And, you know, it depends on the process and the application and what they're doing. And, you know, like I said earlier, if it's small routine maintenance work, then it may well be suitable. It's better than nothing, you know. But if it's a large process and it's all day, every day, it probably isn't suitable.
It's back to exposure potential, isn't it? And the risk and air sampling and demonstrating back to your risk assessment, what is the exposure risk?
But see, we will be viewed upon as the experts. That's why they're calling us in to do their testing. You know, that's what you go on people's websites who do testing, they're all experts. They've all got they're all testing to P601 standards, or they all have BOHS qualifications. Have them put on the side of their van that they're BOHS or HSE approved. They will be seen as the experts. So if that's the case, we need to go in and give that expert opinion, give that view, give people the information they need to make the right decisions.
Excuse me, gentlemen, I've got to leave. So I want to thank everybody for very, very productive couple of hours. I've learned a lot. So thanks everyone. And could I just
see you soon.
Could I just say to Stuart before I leave, Stuart, the value is less than 0.01 ppm, because obviously it can be below 0.01 ppm. So just write that on your card and you'll be safe, mate. Goodbye, everybody, and thank you very much.
Thanks, Melvin.
Thank you.
Yeah.
Bye, Melvin.
Am I right in thinking most of the cloth units you can retrofit a HEPA on top as well? Some of them have an adapter. You can now fit HEPAs to some of these cloth units.
Yeah, it's an interesting point, Mark, because HSE and even the P601 teaching expectations are that if you have a bag filter that's going to recirculate and it's been taken in obviously dust, that it should be HEPA to H13 standard. And that's on one hand, and how do they get away with these inflatable bags? They're nothing like anywhere near H13 standard.
But it's not just inflatable bags. In schools, particularly around us and in Shropshire and North Wales, the high schools are being littered with these underbench dust extraction systems with just polyester needle felt filtration. There's no HEPA filter, and every time you test one, 90% of the systems are passing dust back into the classroom. I mean, I know it's not so much a risk to the children that are in there because they're not in there long enough, but the teachers and the technicians, they're in there breathing that in all day. And they're not tested properly, the doors are never taken off, and then we come in and we fail everything. Like, well, hang on, it passed last year.
Goes back to mis-selling.
Well, the last 3 court cases I was involved in as an expert were all in schools or colleges, and it was all staff from the schools and colleges that got asthma in all 3 cases.
Are they public knowledge, Bill? Is that something we could share with the schools that we work for?
Because they were only high court cases, Crown Court cases, they didn't go to the Court of Appeal, they didn't go to the House of Lords. There's nothing to stop them being reported, but almost certainly they weren't reported. It's a voluntary thing. Reporting of court cases is voluntary. And most of the reporting organisations like LexisNexis and so on, they'll only do it for Court of Appeal and House of Lords Supreme Court cases.
It's almost like we could do with some ammo almost in schools. There seems to be some confusion, particularly if they're run by a central county hall or something. The schools don't seem to take responsibility for the LEV, to say, oh yeah, the central county council should take care of that, and you just go in circles.
Well, that was the last one I went to. It was a lady cleaner in Darwin. I'll name it. It was Darwin, and she went in and cleaned at the end of the working day. But then the evidence came out. She had to go back in and clean before they started the next morning. And she was asked why she had to go back in the next morning. She said, there was a whole load of dust on all the workbenches and surfaces the next morning that I had to clean off again. Of course, that was respirable dust settling out.
God.
And they had the positive pressure bag filters.
And then I suppose probably gas heaters blowing all the dust back up before all the kids getting in the morning.
Yep.
Right, I think we'll wrap the meeting up. But thank you very much for everybody for attending. We will do another one, probably not next month, because I'm pretty sure the BOHS agent will probably be able to confirm this. The best practices virtual events next month.
Yeah, the ILEV BOHS conference, 29th of April.
Okay.
It's virtual, so please all attend. It should be good. We've got a good lineup this year, as every year. Yeah, that's the 29th.
So I'll look to do another one of these in, say, March then, end of March.
May
then, sorry.
May, Louise, May. We're in March.
Oh, yeah, of course. Oh. It's Friday. I'm going to go back to bed.
Thanks, Louise.
No worries. Thank you, everybody.
Louise.
Good to see you all.
Very much, everyone.
Thanks, Louise.
Okay.
All right, take care.
Yep. See you later.
Good to see you all. Bye.
Bye.
Bye-bye.